The number of bacteria NB measured at different times t is given in this table here. I'm going to determine an exponential function of the form NB is equals to n multiplied by exponent of alpha t that best fits the data. And then I will use the equation to estimate the number of bacteria after 60 minutes. So what I will do there is I will click on the return key here, then go to my live editor, then click on code. So the first thing is I will enter this data here. So although our data is appearing as rows here, when we are using commands inside the live editor, we should enter our variables t and nb as column vectors. But if you are going to use the curve vector, going to apps here, then use curve vector, it doesn't matter if you enter it as a row or a column. But in this case, I prefer to use my fitting inside the live editor. So I'll enter this as column vectors. So I'll start with the t there. So I'll say t is equals to, and then enter these numbers so that they appear in a column t. So these are the numbers that we have, and then I will just put a semicolon because I don't need to display these numbers on the screen. Then click on the return key, then enter my n. So I will just call it nb is equals to, then enter these numbers here. So I'll go on and enter those numbers. So we have the number of bacteria there, and then I just put on the semicolon here so that I don't display them on the screen. And then the next step now is to fit an exponential function. So I'll call my function fn, just in short for function, is equals to, and we are fitting an exponential function with one term here. So what you type in is fit, then open parenthesis. We are fitting the exponential function to which variables t and nb that we have just entered. So it's t, which is our independent, and then the nb, which is our dependent variable, then put a comma, then now specify the function that we are fitting. So we said it's an exponential with one term, so open single quote, then type exp1. So this one will give us an exponential function with one term, which is the function of this form here. So I go on and run, and we have our function here. It's saying function f of x. By default, the fit here takes x as the independent variable. So for our function, although we are having t, the default for fit is the independent variable is x. So what is it it's giving us is our function is equals to a times exponent of bx, where a is equals to 6.829 and b is equals to 0.4871. So what we'll be having here is this a here is corresponding to this n, and this b is corresponding to this alpha here. So that is the equation that we would have. We would have that NB is equals to 6.829 times 10 to the power 4, then multiplied by exponent of 0.04871 times t. So that's the exponential function there. But if we just need to check the goodness of it, what we can do is I can put brackets here, and then put a comma, and then just cite g of f. So goodness of fit, so that we say the coefficient of determination there. So we have our coefficient of determination 0.9624, which is an acceptable value there. So we now go on to the next step, which is using the equation to estimate the number of bacteria after 60 minutes. So we are saying that our equation is this one, which is given as f of x is equals to a times exponent of bx. So I'll go on and click on the return key. To evaluate at 60 minutes, we are saying our x now will be the 60, which is the time. So what I'll do is I'll type in fn because we are saying function. So open parenthesis. So we are saying the function at x, of which in this case we are saying we are evaluating at 60. So go on and enter 60 there, and then click on run. And what we would have there is the answer is 1.2695 times 10 to the power 6. What this is saying is the number of bacteria after 60 minutes will be 1.2695 million. So that's our solution there.